Hi students, good morning all. Our today's point is applications of UCM and it is fourth point in the part first. So write down part first and fourth point applications of UCM. Applications of UCM. And in this point, applications of UCM, we shall consider 5 points. First is horizontal circular track. Second is wall of death. Third is banking of roads. And fourth is conical pendulum. And fifth point is VCM. Two remaining points, spear of death and convex bridge, are removed from your syllabus, and therefore write down the first point in the application. First point, vehicle on. First point, vehicle on. Vehicle on horizontal. Vehicle on horizontal circular track. This is our first application. Vehicle on the horizontal circular track. Write down fourth point applications of UCM, in which first application is vehicle on horizontal circular track. Question will be asked on this point is important question. Write down this question VIMP. It will be for 2 marks. Derive an expression. Derive an expression. Derive an expression for the maximum speed. Maximum speed on horizontal circular track. This is our question on this first application. Now, why the word maximum speed is arises in this question? It is our common experience that in case of a horizontal track on the plain horizontal ground, if the vehicle exceeds a speed, a certain speed, then it may skid and goes off the road. While or also if the speed is less than that particular maximum speed, then the turn becomes easier and the vehicle get the turn easily. But so is no minimum speed limit, there is only a maximum speed limit. And so our question is derive an expression for the maximum speed on the horizontal circular track. Write down this question. Now the answer of this question is expressed in 4 steps. First is consideration, second is diagram, third is notation, and fourth important point is the mathematical expression. So write down the first point, consideration. Now, as already stated, the consideration, we must be able to form the consideration form the from the question. म्हणजेच काय तर आपल्याला हे जे कन्सिडरेशन आहे क्वेश्चनवरूनच बनवायचं आहे. आता हॉरिझॉन्टल सर्क्युलर ट्रॅकवरून एक व्हेकल मॅक्झिमम किती स्पीडने जाऊ शकेल त्याचा फॉर्म्युला बनवायचा आहे. तर एक व्हेकल हॉरिझॉन्टल सर्क्युलर ट्रॅकवरून जात आहे असं मानणं यालाच आपण काय म्हणायचं कन्सिडरेशन. मग ते कन्सिडरेशन आपण कसं बनवूयात. कन्सिडर ए व्हेकल इज टेकिंग ए टर्न on a plain horizontal circular track. This is our consideration. So write down this consideration. Consider a vehicle. Consider a vehicle is taking a turn. Consider a vehicle is taking a turn. Write down simultaneously. Turn on a horizontal circular track. On a horizontal circular track. This consideration is formed by using the question. Now the second point is our figure or diagram, and it is also formed by using this consideration. So suppose that this is a horizontal circular track, vehicle is at the edge of the road. Draw this diagram and show the different forces acting on the vehicle. This is a weight mg acting vertically downward. This is the normal reaction, and this is the important force which is Fs. Suppose that this is the center of the road, center C. Now the distance between the center and the center of vehicle is called as the radius of the circular track. Draw this diagram properly. Then we know that our third point is the notation. So write down here notation. Let, comma, m mass of vehicle. Mass of vehicle. Or radius of road, radius of curve or curved road. Now G, acceleration due to gravity. Acceleration due to gravity. And important is normal reaction. Normal. This is important force. Now Fs, force of friction. Force of friction. So in the first application, vehicle on the horizontal circular track, our question is derive an expression for the maximum speed on the horizontal circular track, and the answer is expressed in 4 points. The part of the derivation in the subject physics is about 80%, and therefore I would like to express every derivation in these 4 points. First is a consideration which is made from the question, and from the consideration we draw the diagram, and it is less important point, notation, but for simplicity write down this notation. And so our fourth point is important point called as a mathematical expression. It is a fourth point, mathematical expression. So right here, the fourth point. Now, in this case, for the circular motion of the vehicle, the necessary force of friction, the necessary centripetal force is provided by the force of friction Fs. See the diagram. So write down, in this case, 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 the required, write down this, in this case, the required centripetal, the required centripetal force, the required centripetal force is provided by, in this case, the required centripetal force is provided by the force of friction, force of friction, force of friction. And therefore we write mv square upon r is the centripetal force and is equal to Fs, and this is our equation number 1. Alright, shown in figure. Now how the centripetal force is provided by the force of friction is already shown in figure, and from the figure we are able to form the equation number 1. Now also from the figure we know that the weight of the vehicle is balanced by or normal reaction. Weight of the vehicle is balanced by normal reaction in bracket capital N, and therefore from this discussion the equation is weight is mg and is equal to normal reaction, because this is our mathematical part. So every theoretical concept should be expressed in terms of equation, and therefore from equation 1 divided by 2, therefore from equation 1 divided by 2 we get v square divided by rg is equal to fs divided by n. It is our equation 3. Now this equation 3 shows that r, g and n are constant, and therefore if the velocity or if the speed of the vehicle increases, the force of friction increases, and at the maximum speed the force of friction is Fs is equal to Ms. So write down, it shows that write down, it shows that r, g and n are constant are constants. So if speed in bracket v increases, then fs is also increases. Then fs is also increases. Also increases. And therefore at maximum speed, therefore at maximum speed, therefore at maximum speed, that is at v is equal to v max, that is at v is equal to v max, that is at v is equal to v max, the force of friction Fs is equal to mu s into n. Fs is equal to mu s into n. Therefore, using V max and Fs in equation 3, we get. So write down using Fs and V max in equation 3, we get. So substitute V max for V square. Mu s into n divided by n, where mu s is the coefficient of friction, where mu s is coefficient of friction, and therefore V max is equal to square root of mu s into Rg. This is our fourth equation. So write down, this is an expression for maximum speed on plane horizontal circular track. This is an expression for the maximum speed on the plane horizontal circular track. In this way, we completed the first application, in which we see important question, expression for the maximum speed on the plane horizontal circular track. Now, our next application is the sphere of death or wall of death. So write down 4.2. So write down 4.2, wall of death or well of death. Wall of death or sphere. Wall of death or well of death. Well of death. Write down this second application, wall of death or well of death. And the question will be asked on this point as, write down, this is also VIMP point for 2 marks. Write down question. derive an expression, derive, derive an expression for the minimum speed, for the minimum speed in wall of death, in wall of death, wall of death or well of death. In Hindi it is called as a maut ka kuwa. It is used in the circus. So as we already know that this derivation is expressed in 4 points. First is its consideration. Second is diagram, which is also formed by using the consideration. Consideration is formed from question. Diagram is formed from the consideration. But let us see first about this point, wall of death and well of death, and also underline the word minimum speed. In case of horizontal track, there is only a maximum speed limit, but in case of a vertical track like a wall, in case of a vertical track like a wall, in like this, in case of a vertical track like a wall, if the vehicle is moving on this wall, suppose that consider a vehicle is moving on this wall, and if the speed is less than the certain minimum speed, then the vehicle may fall down, and so the minimum speed is necessary. Maximum, if the speed is exceed than the minimum speed, then the vehicle is remain in contact with the wall. So there is a minimum speed limit. Write down first the consideration. First point is consideration. This is the first point, consideration. We already know that the answer is expressed in terms of a points. So our first point, write down, consider a vehicle is moving in contact with the, you are moving in a well of death. Write down, consider a vehicle is moving, consider a vehicle is moving in a well of death, in a well of death, in a well of death. And from the consideration, let us form the diagram. Suppose that this is a well. Draw this diagram. And if the vehicle is at this point, suppose that these are the tires of the vehicle. Now, we know that the weight is always directed vertically downward. Now, the normal reaction is in this way. And here is a force of friction. And this is a normal reaction. So, draw this diagram. And suppose that this is a center C. Draw this diagram properly. Then our next point is the notations. So right here, third point, let comma m mass of the vehicle, mass of vehicle, r radius, radius of well, g acceleration due to gravity, n normal reaction, fs force of friction, force of friction, and then our main point, which is point 4, the mathematical expression, and it is our fourth point in this answer. So write down the fourth point. It is our fourth point. Right here, fourth point. Now in this case, the required centripetal force for the circular motion of the vehicle is provided by the normal reaction as shown in figure. So write down, in this case, the required centripetal force is provided by, in this case the required centripetal force is provided by the normal reaction, shown in figure, and therefore we are able to form an equation. mv square upon r is equal to normal reaction n, and as already stated, this equation 1 is formed by using a diagram. We already noticed that the answer of this application is also in the similar way as that of the first application. Now, the weight of the vehicle is balanced by the force of friction Fs, and so write down, and the weight of the vehicle is balanced by force of friction Fs, force of friction Fs, and from this discussion we are able to form an equation. Weight is mg and it is balanced by Fs. So write down, this is equation 2. Next step is in similar manner. Therefore from equation 1 divided by 2 or 1 divided by 2, we get we get v square upon rg. V square upon rg is equal to n upon fs, is equal to n upon fs, and this is our equation number 3, and it shows that if rg and n are constant, then the minimum speed depends upon the force of friction Fs. It shows that if r, g and capital N are constant, then are constant, then minimum speed v minimum, or then minimum speed depends on Fs, Therefore, at v is equal to v minimum, the Fs is equal to μs into n, where μs is the coefficient of friction, where μs is coefficient of friction, and therefore equation 3 becomes, write down, so equation 3 becomes, write down, instead of v, write down v minimum. So here v square minimum upon rg is equal to n upon μs into n, and therefore v minimum is equal to square root of rg upon μs. This is our fourth equation, and it is the required formula. So write down, this is a minimum speed in the wall of depth. Write down, this is an expression for, this is an expression, for minimum speed. This is an expression for minimum speed in wall of depth. In this way, we completed the second application in this lecture. Goodbye.